So today I will talk a little bit about the printing in terms of like digital fabrication. For little introduction of myself, I'm an architect. I'm from Brazil. I studied architecture in Brazil, and then I went to Spain to do a master's in parametric design. And then with that, I started working in Fab Lab in Barcelona also. So I started using the machines, connecting the machines, and. Then I worked in some offices in Barcelona, but since then I work in the Fab Lab. I started kind of using the 3D printer or other digital fabrication techniques for myself and personal projects. And recently I was here in Cyprus from January to August doing the residency. I think they have exhibit in the wood workshop. It was a residency of social design, so we did an installation in Turnara, and we finished in August. And here's, I don't know, it's hard to see, it's momamu.lab, my Instagram, and my architecture account is Mateus Sartori. This is just some work that you saw there of I've been exploring in general. I also had an exhibition about masks where I 3D scan 7 people and then I create masks that are custom made for their faces. Or also like some kind of more fashion accessories and I don't know, these kind of things. So this was that I was talking about when I said that I use programming for doing the jewelry, grasshopper. So basically with the same code, I can change all the parameters and create a small collection. So this is how some rings were born. And then today we're gonna do the introduction, the 3D modeling, and then we're gonna do the print file, so we can put it there. And then we're gonna see how long it's gonna take to print and to see what time tomorrow it can be picked up, or another day when you can come here. So 3D print is also called additive manufacture because it's basically you just adding material into this space. One thing that's very important to understand about 3D printing that it's all about layers. So you're always gonna build your 3D modeling, your final thing in layers. So sometimes, depending on the technique that you're using, especially these ones, the layers are quite visible. So you have to understand that they're gonna appear and they're gonna have like an aesthetic of layer, and then if you want to sand it or transform that. In the resin, it's harder to see because it's a very good definition and it's micro layers, but sometimes you can see also. Just in 2000s, the first decade of 2000, that it started to be accessible, and it started because of this project called Rewrap, where basically they would print parts to build another 3D printing. So they were printing themselves. And also with the culture of like open source and forums online, everything was accessible. And then with that, kind of everyone could start having a printing at home. And nowadays, they're very affordable. And in terms of technologies, there is a bunch of types, like more industrial types or the types that we use in general. The extrusion is these ones that are filament, so it's just like when you have solid wire, let's say, and then it hits a lot. Well, here it's better. This is the extrusion that I was telling, and then you have the SLA, which is the resin. So basically, the resin, you have a liquid a tank with a liquid resin, and then there is a platform that comes until the end, and there is a laser that already knows which the position to go according to a 3D model, and then solidifies the resin. So it does the opposite in terms of direction. It builds like this, and this one builds like this. And another one that is also very good, it's not so accessible, but it's the SLS, which is similar process of the resin, but it's with nylon powder. So it's like a big tank of nylon powder, and then you have the laser that goes layer by layer solidifying. And the best thing about this one, that doesn't need any support, because since there is the whole tank, you remove the powder and then the piece is ready in the middle. I will show some videos after. So the most typical one and more affordable is the FDM, which is extrusion. It looks like this, and you can say it's like this, so anyone can buy. Like it's very easy even to have at home. It's not that dirty. You have to be careful and consider some parameters. One of them is the layers. Also, more definition you have like these ones. It's gonna be like maybe double the time of printing, so you have to consider, do you want a prototype, final product, understanding how it works. The SLS is like a little bit bigger. They also have in other sizes, and I will show a little bit how it works.
Design and manufacturing workflows are closer together than ever, but our ideas still often exceed what we can physically realize. A new wave of independent manufacturing starts now with the Fuse One, an affordable compact SLS 3D printer with an intuitive workflow. Selective laser sintering, or SLS 3D printing, is relied on for printing strong, functional nylon parts. In the past, SLS has been too expensive and difficult to use for many businesses. The Fuse One allows you to fabricate production-ready parts and high-performance prototypes. Control your entire process from iterating on your first concept design to manufacturing finished products. The process starts in Preform, our print preparation software. Preform's part packing algorithms can automatically arrange many models in a build. During setup and printing, the Touch UI walks you through every step. Monitor your print from the touchscreen or from your computer via the integrated live camera. Once your print is complete, transfer the build chamber to the Fuse sift. This safe, efficient powder recovery station completes the workflow. Fuse sift will automatically dispense and mix used and new powder after you set the ratio. Reduce waste by recycling powder at a 30% material refresh rate. This means you can print with up to 70% recycled powder. After you've transferred a completed build to Fuse sift, swap out the entire build chamber from the Fuse One for non-stop printing. SLS 3D printing fuses nylon powder layer by layer. The unused powder supports the parts during printing, so you can create complex, interconnecting designs with no need for support structures. Nylon parts balance strength, flexibility, and detail, so prints are ready for rigorous functional testing, or to ship ready-to-use products to customers. It's time to rethink product development and take control of your own manufacturing. The Fuse One, production SLS, finally within reach.
Yeah, I don't know if you understood, but for me it looks like kind of archaeology when you find someone and you have to remove all the dust. It's a little bit like that. And in terms of physical properties, it's the best one because it's really, really, really strong. So I think they use a lot for more, not so much for fashion or accessories because it's very expensive, but more for industrial products. And the one we're gonna use is the SLA, which is the resin type. It looks like this. You can see there also. You can see the prints upside down, and it has the supports. So this one and this one need support. So you have to also consider that, because when you remove the supports, it leaves a mark. So sometimes you have to see if you want that mark, if you need to sand after or no. I will show there is like some process that you can do after that can remove the mark. And in the resin, the mark it's less than in this one, let's say. It's very, very tiny.
Do they have different in their surfaces?
Mm-hmm.
Do they have differences in their surfaces in every print?
When
Like if it's in the sand, it might have like the small.
like the texture.
Yeah, the
yes,
texture.
yes, they have different textures. I know the nylon one, they have a lot of post processing techniques to make very smooth, because they have this kind of I don't know how to say it, but powdery surface. This one it's much more smoother, the resin one, and this one you usually can see the layers. So, but also depends on the materials that you use. And the definition and what you do after, but yes, they have different surface because they're different materials.
Well, this is an example of
The nylon one, yes.
The celeste is the sand, no?
Yeah, this is the nylon powder. With the laser that solidifies it slowly.
How much are one of those machines? I mean, that video said it's more affordable now, but I mean, it says that is like not for a person, I assume for a business, right?
And you can Google it. This company sells to everyone. So if you Google it Formlabs SLS, you will see the price. I'm not sure exactly how much it will cost. Maybe 30,000. It's not affordable. It's affordable for business.
This one is also resin.
Yeah, that's what it is. That's flexible.
You can see it's a flexible resin. This is the castable resin. And you can see the support, the points. You can test that.
Is the filament that makes it rubbery?
It's the material, yes. It's a flexible resin.
Flexible resin?
Yes, yes. You have even like I think some kind of ceramic based resin where you can fire and then have some ceramic finishes.
This is printed.
Yes.
And what do you use? What can you do there?
Aranto y Google.
This, for example, if you want to design for fashion, for example, you can design I don't know, some like nails, stuff.
I never used the flexible one.
Flexible, like this kind of machine.
No, it would be hard like to do the mask that they did and they're a little bit more flexible.
Yeah, because you can use like a flexible thing, but the other one like this one.
Another like this. I'm gonna post another video.
All 3D printing technologies create solid parts from 3D models layer by layer. Among them is SLA. SLA stands for stereolithography, a 3D printing process that uses a UV laser to cure liquid resin into hardened plastic. Upside down, or inverted stereolithography, is the most common SLA system. Depending on the machine, resin is either poured into a tank by a user or dispensed automatically from a cartridge. At the beginning of the print, a built platform is lowered into the resin, leaving only a thin layer of liquid in between the platform and the bottom of the tank. Galvanometers direct the UV laser through a transparent window at the bottom of the resin tank, drawing a cross-section of the 3D model and selectively hardening the material. The print is built in consecutive layers, each less than 100 microns thick. When a layer is complete, the part is peeled from the bottom of the tank, letting fresh resin flow beneath, and the platform is lowered once again. Originally developed in the 80s, SLA was confined to large industrial machines until recently. Today, desktop stereolithography offers affordable, high-resolution 3D printing that fits conveniently in your workspace. SLA allows for the use of a wide range of materials with diverse physical properties. Whether you're an engineer, product designer, sculptor, jeweler, or dentist, there's a material for your application.
They use this a lot of dentists use a lot of this for making molds, like teeth molds and.
But then the top part is always flat and then it comes.
No, because you have the. I mean, yes, but your model is kind of floating with the support, so it doesn't need to be flat. The model.
But like that tiny one that we saw.
Ah yes, but you remove it. You remove everything and it just keeps the ring.
And how long would it take to make, that sort of sped up that video we have seen?
Oh no, that was very fast.
Because it depends on the size of the thing.
Yes. Sometimes it can, like if it's a big size, can be like 1 day or even more.
Oh wow, so
Yes. And also depend of the layer that you put and the material and machine. But sometimes I can print like a ring, small ring, 2-3 hours. Depends. Yeah. No.
All 3D printers.
So you can use for a lot of things, medical use, dentistry, and jewelry, which is something we're trying to focus today. This is just like the mechanics of how it works. So basically, we have the tank here full of liquid resin. And then there is a laser that comes underneath, mirrored, and then the laser goes into the liquid, and then it knows the points where it should solidify. In terms of parameters, it has less parameters than this one, for instance. It's a little bit more simple. You just need to know the layer height, exposure time. Exposure time is basically how many seconds the laser is going to be in that layer. And depending on the type of resin, sometimes it changes. You need more seconds or less seconds. Lift speed is when it goes up, like you finish the layer and then doof, and then it comes back. And these kind of details that you start understanding when you start to use more and more, and also a lot of try and error.
Do we need manually to make every? I mean, is it doing
No,
automatically?
they have the software, the machine that is just like poof, poof.
Yeah, we don't need to say.
No, depends. If you change the resin, sometimes yes, but then they give you like the parameters that you have to put, and then you just write them down. But yeah, also like with the resin in general, you have to wear gloves, sometimes masks, because the resin is toxic. And then you have a post-processing that I will show also that will remove the toxins. Also have non-toxic resins, but the cheapest ones are a little bit toxic. So the orientation, usually the best orientation for 3D, this type of 3D printing is this one, because the idea is that when you cut the piece, like a section, it should be the smaller section possible. So if you have like this and you cut this whole thing, you have a big section. I don't know if I explain. Like when you cut it like this, do this, like this, I cut like this, all the touches is like large. And then when I do this, it goes less surface, so it's supposedly to be better. Because sometimes you can have some fails.
It means less marks?
Less surface. That's the idea. Like if it's like this, it's worse than this. Because when you cut it.
Why is it
I think it's because
Maybe layer adhesion, I think because you have larger surface.
Exactly.
More, maybe it will fade.
yeah, sometimes the laser is like cannot reach all the surface.
But for a ring, it's flat, right?
For a ring, it's fine because it's a small thing. But when you start printing bigger stuff, you have to be a little bit smarter.
Is it the same for FDM?
No. FDN is totally it's the opposite. FDN is more about the angle and supports and being very vertical or horizontal.
And the disposition, do you need to put for your set, or the machine can
Usually they have an outer orientation, but sometimes you can change. And even the supports like this one, sometimes you can add manually supports, but they have a configuration that it's automatic. And here I think you can see this, for instance, is like a phone case that they was 3D printed with resin. And then you can see here that you have some marks. So it's good to understand the product. For instance, since here is where you're putting your phone, this mark you're not gonna see it, so it's fine. So it's good to orientate your product where the mark is gonna be in the hidden place or something like that. This is to take into consideration. And then the post-processing for this, basically most of the resins, when you print, you have to have the gloves on, everything, remove it from the platform. First you have to clean and wash in alcohol or water, depends on the resin, so it removes the toxic. And then you have to cure in UV light. So there is that machine, the orange one, you put there like a stove and then it curates. And then when it curates, the resin gets even more solid. Because it's a little bit not so strong. So you need to curate to put to make it more rigid. And then my process for doing the silver jewelry is basically the same as the lost wax casting process. So I 3D print them with a special resin. And then I go to the jewelry maker. They usually do a tree, I think like these ones. So they just put the piece in this tree and then they cast the whole thing. And then they give me the part that is just my thing and I finish by hand, polishing and all that.
What is the tree for? Is it just the support?
They put all of this on a tube of plaster. So they inject in the top with melted silver, and then it goes into the resin, destroys the resin, and occupies its place. That's it. I never seen done this, but I've seen a lot of videos.
I think the tree is basically to be able to do multiple ones at the same time.
Yeah, exactly. Because it's quite expensive, yeah.
And then in order to do that, you just need a core.
And the metal flows down the trunk of the tree, basically goes out.
Yes, yes. And I mean, also after you have also the mark of this thing that connects, and then you have to polish and remove it by hand. Whoever's interested about 3D printing, this is a very good source. It's online. It shows all the different types of techniques and all the parameters. I really like this because it's very nice design. And usually it's hard to find technical things that are nicely designed. And usually I use this when I need. It's called the 3D Printing Handbook by 3D Hubs. Also you can get the book. And then now I will show some examples of real life products, let's say. If anyone knows Iris van Harpen, she's like the pioneer of combining digital fabrication techniques into fashion. And this is a dress that is all 3D printed. So she 3D printed all these small, I don't know how to call, like, yeah, like coral types, and then she placed it by hand one by one. This is also a piece that is fully 3D printed in one piece with nylon. Other 3D prints with modules. This is probably assembled as modules and created the shape.
I collaborate within my work with architects. In a way, the knowledge that lies within architecture is very useful for material development on the smaller scale. So really translating techniques on a larger scale into fine textures of fabrics. My crystallization collection was my first time I collaborated with architects. The architects spent Macau. They were working with 3D printing back then for their model making, and I was really fascinated by the intricacy in detail. When I started with 3D printing, I was using it very much the way an architect would be using it, but now the knowledge of fabric making is really implemented in the way we work with a 3D printer. For example, collaboration with the University of Technology in Delft, where we created like a tool fabric that was woven, but then was put into a 3D printer, and the 3D printer becomes more like a new form of embroidery, I would say. Recently, it was turned the other way around, where architects asked me to collaborate on a large-scale architecture project, which is Naturalis, which is a national history museum here in the Netherlands. I've been working on the stone development, like three-dimensional panels that run all the way in and outside of the building. I wanted to add some softness to the building, and of course I can't bring in the softness of my work into a scale like that, but I did want it to look as soft as a garment.
No. She's like, if you're interested in fashion and new techniques, she's the one. She used a lot of laser cutting also, and very experimental in terms of fabrication. This is of kind of studio called Nervous Systems. They work a lot of 3D printing also and research in parametric design and all that. And they created this dress that is printed all at once with these kind of connections here in between the triangles. And then it comes kind of in a box of 3D printing, and then you can open it. You can understand a little bit more with this video.
One of the biggest challenges in trying to make a garment using a 3D printer is that 3D printers print rigid, hard plastic.
This project actually started with an idea to create a bracelet that was made out of hinged components that could print flat and then fold into a three-dimensional configuration. And we thought it would be amazing to make something larger scale like a dress. We take something large and three-dimensional and fold and flatten it using simulation to make it small enough to print in one piece.
So the entire idea of this hinges on when we take it out of the machine, it unfolds into a dress.
Part of the idea of this entire project is being able to make complex, large-scale things with no assembly required.
So we were experimenting with creating hinged textiles, which in a way are sort of like chainmail. They have a hardness to them. They're made of a hard material, but they're interlinked in such a way where they can move and you can run in them, you can sit down in them. They're not a hard plastic cage around your body. There's a lot of garments that have been printed in the past that were giant sculptures were printed in tiny, itty-bitty little pieces and then hand assembled, which is really doesn't even necessitate being 3D printed. That's how you would make a traditional garment or sculpture. How can we adapt simulations that biologists are using to understand how form and pattern emerge in nature and the nervous system? Those are the sort of experiments that we've been doing. And this dress is sort of our latest project of combining engineering and science techniques with design and visual fabrication.
Also, other projects from Nervous System Studio where they explore the generative design of shapes that they're inspired by nature. This is a collection they have of 3D printing jewelry in porcelain and also in other materials like gold, silver. So you should check it out. It's quite cool. This is a project from a Brazilian architect, which is just very interesting. Also, it's called Aura Pendant. So basically, you have an app in the phone where you tell your story, and usually it has to be kind of, I don't know, love story or like sad story or whatever. And then with the audio, you can perceive your heart and your beats and these kind of things, and they transform in a generative design. And then you can 3D print your own piece based on this audio and this story that you're telling. You can also apply this to more delicate fashion approaches. So all these small flowers are 3D printed to have necklaces. This is a company in Spain called Come the Machine. They are specialized in 3D printing. And also in the cinema, this crown was all 3D printed. And more like research based type of 3D printing in resin from Filippo Nassetti. This is another way of using 3D printing with the 3D pen. So you can use the 3D pen that they have here and create sculptures or even fashion. Betiana Pavon is her, so this is her artwork. And all of this was, I don't know, you want to explain? Or can I explain? And this was the collection we did together with the concept of bubbles. And this for me is a very cool reference of shoe design. He created these very futuristic kind of shoes. It's called Skylab, and they all 3D printed also. And this project is very cool because you can scan your feet, and then with that you send to them, and then they create a perfect 3D printed shoe adapted to your feet. And I think in terms of future, 3D printer is gonna be used in terms of like design, prototype, and it's important to understand what are the techniques and how we can use it. And nowadays it's very affordable in terms of especially the resin ones. I have like 2 at my home. I have also one that is filament, and if you're interested, it can be easy to find information. So some final considerations. First, you have to understand the technologies and materials, all the parameters, depending on these choices, and then especially how to use the support and the post-processing. So, and plugins and softwares that we used, I use a lot of the Cura and Prusa for the 3D printing part. And then the 3D modeling, I use especially Rhino and Grasshopper, but then you have a bunch of other softwares that are equally good. And one that we're gonna use for the AI is this one, is Luma AI Genie. So this, I put also this reference as Tinkercad for people who has no experience also with 3D modeling, because it's a free software online that you can 3D model with very simple shapes. And here I put some reference for using the Cura. Here you control all the parameters. This is for the filament one. Process slicer. Also literature references for 3D printing. with Grasshopper, if anyone is interested. And usually, where you can find these kind of places are places like this, like science, or universities, or I put these references here. They're all online, so you can even send a 3D model and ask for a code, and then they can send you or not. Depends on if you want. Like shape waves, this is a very good one. Materialize, I think it's the one in the UK. Hubs, the one that I showed the book. And this is Wiki Factory. And now, it's time to model. It's like, okay, this is a little bit cleaner, doesn't have the things. And it's not necessarily sad, but it's cheap. Side of course inspired. And then to make it more quality for then downloading, you can make it here. It's called make rise high resolution. This it does take a little bit of time, so I will leave it doing that. And you can always come here in our creations. All the things you have done. For instance, I was trying like a mosquito ring, or I was putting like a pomegranate ring, or I don't know, things.
Did you use any of these models for design?
No, I'm trying to do all of them like proper modeling. But I like this idea of exploring and see what AI gives you when you say these words. It's interesting. And then, for instance, I want this, and then here in the custom, you usually just choose the format. So you have STL, object. Usually these two are the best for 3D printing, either STL or object. And then you can even export and use in 3D modeling software, and then just put download. And it's downloading. And then, for instance, now we have the 3D here. I can open the Rhino, which is the software I use. So when you put high resolution, it takes a bit, so be sure of the design you want. It's a little slow. What else I did that I liked? I think there was some ones in the beginning, there was a little bit, like I put alien-inspired ring. Parametric, extremely crazy and complex, somehow did rings. Sometimes it doesn't understand well, but like the octopus also. Or some of these. And then with this, I can understand the size of it. Because for instance, if I do a bounding box, I know that this is 1 millimeter by 1 millimeter probably. Yes. So if I want to print it bigger, it's too small. I just scale this. So before like printing, you have to scale according to the size of what we want. So it's not tiny or super big.
So we put in the 3D software just to scale.
Yeah, I mean you can modify it if you want, but the thing is you have to know how to use the software. But I can like I don't know modify like this.
I can see cycle. can be.
Because the Luma AI thing that I tried with it is like a human animation.
Oh, it's luma.ai/Genie. Because the Luma also they have video AI that you can do video with it.
And is there a free?
It's completely free.
That's free. I'm gonna try the same one.
Genie like this. Luma Labs. Maybe the S. Yes. Next time, don't even try. Just call me.
Sorry, can you also use like Blender?
Yeah, to modify. Yeah. I mean, after when you have the STL of the object, you can put in whatever software you like.
Is there a free 3D software like Mango that we can download?
Well, the one that is free, that it's very simplistic, but maybe it's good. Is called Tinkercad. Yes.
Blender as well is free.
Blender is also free. Yes. And then here you just
So that's maybe like how it is.
No, it's like that. Yeah. Yeah, the Tinkercad works with basically base shapes where you can add and subtract, and you have this display where you can place them, and it's quite intuitive. I should put it in English because it's in Spanish. But here you have all like the like basic shapes like a wing. And then you can see that you have the edges, so you can change it or not, or you want to rotate. And then you want to add a star. It's a little bit more like constrained to the tools that they have, that they're these shapes, but I think they have like a free thing that you can draw on. So I don't know if I like this shape.
Is it air? No, you need to put the G after. It's the it's in the right.
Yeah, this is good because it's free. Who is starting on 3D modeling? I think it's the easiest option. Sí, sí. I think sometimes you can even like press on this side and make creative. So in electric crystal, después podemos usar hairs. No, ele quer ser missão. Pode sair e quer ser missão, mas daí ele te dá o prompt, ele pode usar e depois até modificar como ring, bracelet, porque às vezes tem uns que já estão mais definidos. Você tem que mais específico. If anyone needs computer, you can use mine. Who wants to try this? Or are you okay with the AI? Like mine is free. If you want to use it, so it's free. But if you're good with the AI, I can just connect them
Everyone will watch you. Lots of pressure.
all eyes on you.